Hello everybody, welcome to my class. So in this short video I will discuss about, let us go to the course content and then let us go through learning modules. Then you will see module 1, it's learning module 1, algorithmic thinking. So if you click over here, you will see there is a PowerPoint presentation. So if you click on this module, you will see your PowerPoint presentation like this as a PDF file. But if you go through, if you scroll down from right side, a larger scroll bar, then you will see a download button over here. So click on this download button, then it will be downloaded. If you click on this download button, then it will be downloaded as a PowerPoint file. If you see module 1 M1 slide, and it has 18 slides, so you can go through this way, or I like you to download this as a PowerPoint file and then open the PowerPoint file using a PowerPoint viewer, and then you can go through this and you can edit and you can keep your note and you can add something. So I have already downloaded this PowerPoint file here and I have already uploaded here in my PowerPoint slide. So let us go through this. So the module 1 is straightforward. It is the title is algorithmic model. So the motivation behind this module is to learn algorithmic thinking or computational thinking, which emphasize on pseudocode development to understand what an algorithm is and how to write an algorithm, and to appreciate the role of algorithm and algorithm development in computer programming. Actually, let us go through this, and these are the main topic. What is a computer science and what is programming, what is algorithm, these are the contents of algorithm. So definition, properties of good algorithm, describing algorithms, examples and components of algorithm. So let us go through all this. So what is programming? So if computer programming is writing, not only writing programming code. So in a specific language, actually computer programming is to solve something, to write some source code in order to execute the source code using a computer. So to become a good programmer, the knowledge of a particular programming language is needed, but that is not the essential thing. That is the secondary thing to learn a specific programming language. But the most important thing is the ability to solve problem. So why we do know that a computer can do something very quickly and very efficiently and correctly. Why? Because we can write a program and execute a program on computer. That is, a computer is a machine that can be programmed. Okay, so this is why a computer can do a wide variety of tasks, because it can be programmed. Computer is a machine. But once we write program on a computer and execute our program on a computer, then it can when a program runs on a computer, then we see a machine becomes an active things, or an active machine that can do a wide variety of tasks. So So programming requires two skills. One is algorithmic thinking or computational thinking, and second is knowledge of programming language syntax. So as we have seen that we write programming language syntax using a notepad or IDE. That IDE we showed earlier that we use Eclipse for Java, and for Python we use idle, and for each of the programming languages there is one or more particular IDEs. So learning a language syntax is the easiest part. It is not hard. Okay, programming start with algorithm development. Algorithm development captures and describes the program task in correct order. Syntax development is derived from algorithm. So the thing that it says, learning language is easy, but syntax development is the derived from of algorithm. So once we understand algorithm, and then if we can develop an algorithm, then it will be easy for us to develop a program. Okay, we will see, we have already seen that how do we write programs, and but we need to understand how do we write algorithms. So throughout this course you will learn how to write algorithm with various examples. So how to learn computer science? Actually, in order to learn computer science or to be successful in computer science, you need to learn how to write algorithm. So initially we will write algorithm using pseudocode, and then after we will implement that pseudocode in a computer program using a specific programming language. As you know, a pseudocode is programming language independent, but a computer programming is a set of instructions that enable the computer to solve a problem or perform a task. We will come that later. So first of all, in order to develop your algorithmic thinking or computational thinking, we need to start with writing pseudocode. Okay? So pseudocode is the thing that we will write in order to understand the logic and in order to understand how to solve the problem. Okay, so that pseudocode will not be run using a computer or a compiler. That is for us to understand the concept, how to the problem is solved, and then we have already seen how do we write a program using Java, and then how do we execute our program, and how do we debug it. So but at this time you will see a lot of programs available online, a lot of source code available online, but just getting source code from online is not a good way to understand programming. Okay, to learn programming you have to understand the basic concept, and you have to understand the logic, and you have to understand the steps how to solve the problem. Once you understand the steps, then you can easily implement your pseudocode or algorithm into a programming language. So now let us come, what is an algorithm? You already know that, right? An algorithm is a step of is a set of logical steps to accomplish a specific task. Okay, so like it is a recipe of action, and this is a way of describing behavior. You can say that in another way, it is a set of direction of instruction to perform a task, or to complete or to solve a computer problem, solve a problem, any problem that could be a real life problem. So An algorithm contains two things: data and instructions. Data, in order to use data, in order to hold data, we use variables, and there are different data structures based on the size and type of data. There are also data types. So we will go through this. We have seen some basic and or custom data types. We will see more. There are more data types, and we will be able to to develop our own data type that we call class, the custom data type. And there are instructions. Algorithm contains instruction. Instructions are the steps, specific steps, and that are executed is in every steps. This algorithm contains two things: data and instruction. Okay, so how algorithm works? So in a computer program or in an algorithm, we will give some input as data, some as an input, and then there will be some process or steps in that are the main body of the algorithm, and then based on the process or action or task, there will be expected output data. So data are given as input, and that is found as also an output. So data is given in input as one format, but it is retrieved or it is found or expected to give us output in our expected form or another form, not as is that is given as an input. So we will see. So here is a state card. Here is an algorithm over here. So this algorithm, it has some data. You see, data are the ingredients. Okay. So and there are some instructions. This algorithm is for chocolate chip cookies. How do you cook your chocolate chips cookies? So as you go through this, so you have this data like this 2 1/4 cups of flour, and then baking soda, some 1 teaspoon soda, and then 3/4 cup brown sugar, and then you have salt, eggs. These are like specific type data you have. And then you have instructions. So instructions are the steps you have to follow in order. So for instance, you have to preheat oven to certain like 375 degrees Fahrenheit. So or Celsius or Fahrenheit. No, so but you have to follow this instruction by order. So if you miss these steps, your algorithm will be incomplete, or your problem may not be solved, or I mean your chocolate cookie will not be cooked. So then you have to do these steps fast, and then you have to heat your oven fast, then combine your flour, salt, baking soda, and you have to combine sugars, and you have to add egg, and then you have to dry mixer, and you have to go through until the last steps is bake 8 to 10 minutes. So even if you miss either this step, or if you swap these steps from here with this and the first and last step, it will not work. So you have to remember that while writing an algorithm, you have to think about the steps and sequence. Okay. So then there is abstraction. Abstraction is a concept. In order to write algorithm, or in order to think computationally, or in order to think algorithmically, you will think in a way of abstraction. Abstraction is a, an idea in general terms. So it is an impractical idea, visionary or unrealistic. Sometimes you will see we'll talk about abstraction. Abstraction, you know, when you read when you get a large like 10 page or 12 page paper, okay, so there is a, you will see at the top there is a one paragraph very short abstract. So abstracts tell us the what is written in this paper in a very shortcut way. Okay, it will give you the theme, but it will not tell you specific detail. Okay, so in computer science, okay, abstraction refers to the logical grouping of concept or object. So when you we will understand this logical grouping when we understand class and object. So define and implement the logical idea or isolate, hide the implementation in detail. The concept of abstraction is that you will give the just a general idea, but you will not tell okay, so how this is implemented. So here is actually implementation will be done in another place or in different ways or in multiple ways, but in abstraction just is an idea, and it just tells you the concept but not the implementation detail. We will know abstraction later. So then what is the use of abstraction okay, in computer science? So abstraction in computer science is used for algorithm development. Okay, so an algorithm development while you have to think abstractly. For instance, here so if you ask someone, for instance, how to go to Clayton State University IT department from here from CSU campus, so then you so one route could be, or if one of the possible, there are definitely multiple ways to multiple routes to go to go to the Clayton State University campus from KSU campus, but okay, this algorithm says from Atlanta. Okay, so there are multiple ways. So one of the ways should be these ways. So these ways, so go get on route I-75, then exit on 234, then turn left, turn right, and then following these. Okay, but there may have other ways or other routes, definitely, right? So so as long as you arrive to your destination place, your other route should be fine. But so here the abstraction is to get to the Clayton State University IT department from Atlanta. Okay, but you will this is the abstraction. How, so think about how do you go there, how do you drive over there, and in the actual way how it will drive over there, that is an implementation of that abstraction, and this implementation is called an algorithm, a process or some set of steps how we implement that abstraction. So we will know abstraction and algorithm throughout this course. Okay, so what is wrong with this algorithm? Can you figure out? Okay, from back of shampoo bottle. Okay, this is good. So you are given some direction. Okay, so how to use shampoo while taking shower, and okay, so actually look back this algorithm. Okay, so this algorithm, okay, this algorithm. So one thing that it has begin and end, right? And the steps are written sequentially. But okay, for this is not a complete algorithm. This has some steps, but these steps are not written in an actual order that we do usually. So this is why it is, and it has no end. Okay, so it says repeat, that means you will be continuing this steps, so there is no end. So it does not say when you repeat it, when the repetition will be discontinued. So this is the main flaw of or mistake of this algorithm. So we will see how to write good algorithms using some examples. So a good algorithm should have these characteristics. It should be precise, it should be unambiguous, it should be complete, it should be correct, and it should be simple, and it should contain level of abstraction. Okay, so this is the thing, level of abstraction. We will see, we'll read about know about abstraction later on, while we give concrete examples of some algorithms. Okay, so another thing that an algorithm should be precise, unambiguous, and it should be complete. Complete means it should have a starting point and specific ending point. If it does not have any ending point, then it will see your algorithm is incomplete, or it is a bad algorithm. For instance, is a wrong algorithm. This does not. For instance, algorithm does not have any end or completion. So describing algorithm, how do we describe algorithm, or how do we write algorithm? We will write algorithm in natural language, like almost in natural language, but we can write algorithm in multiple ways. There are several ways to describe your algorithm. You can describe in natural language. You can draw your algorithm by drawing a flowchart. So picture or flowchart, this is also description of algorithm. And you can describe your algorithm by pseudocode or a specific programming language code. So in order to learn algorithm, okay, or in order to learn computer science, or in order to learn for this course, you don't need to write your algorithm in a specific programming language like in C, C++, or Java, or Python, or C#, but you need to know how to develop your algorithm either in mainly we will use pseudocode, and pseudocode we will write our pseudocode in almost in natural language. And I have shown you that how to write pseudocodes, and we will see we will write a lot of pseudocodes in our program, and we will demo pseudocodes. Okay, pseudocode will be used in this course. So that means writing algorithms have algorithm has multiple ways. You can write in straightforward language, or you can draw your algorithm, or you can write pseudocode. Okay, so this is an algorithm. This is written in plain or pseudocode type format. So this is an algorithm. It says, for instance, if you want to register one of your desired courses at KSU, so these are the steps you usually follow, right? So these are the steps you usually follow how to write a pseudocode, how to register in a course. So you will first make a list of courses you want to register for this semester, okay, in order of priority, okay, and then start with an empty schedule, number of hours. With an empty schedule, you will have your number of hours 0, then choose highest priority class on list. Then you will see that you will check if the chosen class is not full and its class time does not conflict with other classes already scheduled for you. So then you will register for the class. Then when you register for the class, then two things will happen. One, will add the course, the course will be added to your schedule and your number of hours will be increased, okay, to your number of hours. So that means your number of hours will be added. So add the class hour to the number of hours in your schedule. So then cross out the class of your list and then repeat then the thing. So if you have multiple courses to register for this course, then definitely this you have to repeat these steps 3 to 5 until you complete all of your desired courses, or you exceed your like maximum of 15 credit hours in a semester. So then once you are done with step 6, then you have to stop. So this is the main thing important. Then you have to stop in a certain place in an algorithm or in a program. You have to stop, otherwise it will be continued infinitely. So that is not a good thing that we for an algorithm. So you will see that sometimes you will forget to stop, but please remind even me if I do forget to stop. But also I want to remind you that you have to stop in an algorithm, otherwise you will not be a good algorithm. So this is a straightforward algorithm written in plain English, but if you go through this next slide, you will see this the above straightforward algorithm can be described in using a flowchart. Flowchart has some specific structure or symbol. For instance, begin or end, these have oval type. Begin and end, these are oval type, so you must use oval, not square or rectangles over here. So then you have a rectangle for input or operation, either operation, input or operation. These are the input, these are the like operations, and these are the like operation. Okay, so, okay, and you will use what is it called, diamond type. This is thing for you will use for decision making. So to take a condition over here, so if it is true, is a class full, then yes, then it will go, it will flow to these actually, and if it is no, then it will go this way. So that is this is a way and this is an alternative way. So either you have to select either one. You cannot go through this way and this way simultaneously at a sense or parallel. You have to choose either way. So your algorithm should have specific condition over here. That condition, if the condition meets, then it will go through one way, and if the condition does not meet, then it will go through another alternative way. So the most important is that in writing flowchart, you have to start, you have a starting or beginning point, and you have an ending point, and you have some input and process and some checkpoints. These are the checkpoints. Okay, and pseudocode. Then I have shown you in the first year experience phase, there is a good pseudocode resource over here. So if you go through this resource, then you will know how to write pseudocode and what are the general rules and restrictions of writing a pseudocode. Okay, so this is a simple pseudocode. This says, okay, pseudocode to print the number of sides of geometric shapes. For instance, you have a class geometry, and then, so for instance, class, or it could be a method of geometry, and it says end. This is actually then it's begin, and this you have end. Okay, and then you have a method over here, so this main method, and then you have a end of this main method over here, and with beginning of your main method. Okay, so you have assigned so let's, if your size gets value, this is the variable, actually this is the slice will be variable. If it gets value 7, then we will print a heptagon. Okay, so like this, a heptagon has 7 sides, and if you get 10 sides, then you will type in a decagon. This is a decagon, has 10 sides, and if you have 12 sides, then it will be a dodecagon. So for instance, based on your input, you will see your output this. Okay, so this so look at that, this algorithm does not have any conditions. So all this line will be printed, and also this line will be printed after that, and after that this line will be printed. So this is why it will print all 3 lines as the output. Okay, but in our other algorithms, we will see based on a specific number of side with condition. So we can write our algorithm so that either it will print this line or this line or this line according to a specific number side. Okay, so component of algorithm. So as I just stated at the beginning of this slide, so any computing algorithm will have at most 5 kinds of components. These are the essential parts of an algorithm. Okay, it should have some data. So based on the nature and types and size of the data, we will use different data structures. Then, for instance, array, linked list. So you will learn that in this class, and then we will have some instruction to work on data. So then instruction will be implied on your input data. Data will be taken as an input, and then you will execute, you will perform some operations on your data. So then sometime you will see some conditional expressions, and you will see some control structure, control statements. So conditional expression are used to make decisions, and also control structure are also used for decisions. Conditional expression are used mainly to take decision to if you have certain conditions, or if your condition meets, then it will do something, and if the condition does not meet, then it will do something else. And then you have sometime, if you want to do something multiple times or iterate, then you will use control statement. You will see that. And you will have module. Okay, so module, you will use for module or method, for instance, a group of related code or instructions you will use in order to write our in order to make our algorithm precise. For instance, using methods. Okay, so if you have seen our program, then in our program we will write we will use print. So in the previous class you have seen that. So while writing a program, so we use some method, right? We use some method. So this method is abstracted over here. So it says the computer or the compiler to print something on the console, but we do not know, or it does not say how it prints or display our result on the console window or on the monitor. So there is an abstraction here. So the abstract thing is that our print method does not say in detail how it is displayed on the console window. Okay, so we will see that this is an abstraction of using, but for instance, by using print method or println method, we are executing a bunch of statements behind. Okay, so then if otherwise we had to write a lot of other a setup course every time we want to print something or display something on our screen. So then by using println method, it is our coding becomes easy and concise. Okay, so it says we use modules. So module here, for instance, or module or method. So there are some modules and method used here. Okay, and then this is the last part, conclusion. So conclusion, let us go through this before we wrap up. So algorithm thinking is a crucial for success in computing. So algorithm thinking, so in order to success in this course, you have to think algorithmically, and you have to learn how to develop algorithm, how to increase your algorithmic thinking. Okay, and how to develop algorithm. So your program development will start with writing algorithm. Okay, so you will not start your first programming concept with by writing program here on IDE and executing program, or getting program source code from online or from somewhere else, and to understand the problem computer program. Not that. Your first step will be you write your algorithm, scratch your algorithm on a piece of paper, or even on your head or in your mind, and then start developing your algorithm with pseudocode, or then first and then later using program code. Okay, so algorithm, what is algorithm? An algorithm is set of instructions to perform a specific task. So an abstraction is an idea or is a concept to describe an idea that at a high level with little details or hiding details. Okay, so abstraction will not tell you how to do this. It will tell us that it will give you some hints that something is done over here. Okay, so something will be done. So implementation of an abstract idea is the algorithm. So algorithm, actually through writing algorithm, you will increase your abstract thinking. So when you get an abstract idea, abstract or that your invisible idea, so is shortcut idea, you have to implement or expand your idea by writing algorithm. An abstract idea can be implemented in different algorithms. Yes, as we mentioned, that you can go from here to downtown in using several routes. So likely an algorithm can be executed or implemented in multiple ways. A good algorithm exhibits precision. It should be precise, it should be clear, it should be complete, and it should be correct, and it would be very simple. It would be as simple as possible. An algorithm can be described using a natural language like human language, in English definitely, and it can be it can use pictures and diagrams. If you draw that algorithm, implement that algorithm using flowchart and pseudocodes or a specific programming language. So you will see some algorithms are more closely to a specific programming language, like Python codes are almost same for some algorithm. So okay, so before we conclude this, let us go through our D12 system. So if you go to quizzes on your D12 system, then you will see that you have quiz 1 and next week, and you have quiz 2. So some of your quiz questions from quiz 1 will be from this slide. So this slide, so please go through this slide in order to be prepared for quiz 1. Okay, so then quiz 1 will be pretty easy. And then before I wrap up, so let us go through a simple program over here. So this is an IDE, and IDE is called Integrated Development Environment. Okay, so it is not, remember that an IDE is not a way to express your algorithm. If you write, this is a way to write your program, to implement your program. Okay, so if you tell me, okay, this is my algorithm, then I will not, I will laugh out. Okay, so actually this is not your algorithm. So this is a program. Okay, so this is an implementation of your algorithm. Okay, of an algorithm. So in writing algorithm so while for writing algorithm we will not use an IDE. Okay, so that is when IDE is not a method of expressing an algorithm. So what are the methods of expressing an algorithm? We know that flowchart, pseudocode. There are also UML or other tools, other programming language tools, like other tools. There are some other tools, UML. You may have that UML that is called Unified Modeling Language, UML. If you do ML, if you wiki, if you do Google search about UML, UML is a tool. UML is a good tool I use sometimes. It's called Unified Modeling Language to draw your flowcharts, and after that, when you draw your flowchart using UML, you can use some specific languages like Python in order to write some pseudocode, write some code, implement actual codes from your drawing. So that means if you from your flowchart. Okay, but as you know, so when we type in our program over here, so it is easy. It's compiled. It's automatically compiled in Eclipse or Ideal IDE or other IDE. Okay. So and while you write your program in an IDE, it is easy to detect your most of the time easy to detect your syntax error, but sometimes it is difficult to detect your logic error. So actually we write, these are the actually fourth generation languages. We call fourth generation languages, like almost in human language like in English. Okay, so please go through this slide and this go through this slide and go through this video, and if you have any question, then please let me know, and we have time and we will repeat some of these things in our in our next classes, so before we face quiz 1. So thank you so much.